Okay, finally I'm ready to start. It took some time to get here, and I think I was about over 10 minutes late. Sorry for that. I hope you hear my voice. I'm taking one title which I have forgotten to handle earlier, and it should have been in the quite beginning of the course, but I've forgotten that totally. I will take simultaneous equations. Simultaneous equations, or you may also call this multiple equations or system of equations. In Finnish we call this yhtälöryhmät. Yhtälö is same as equation. And ryhmä, or in plural it's ryhmät. Ryhmä is, if we translate it. Oh, sorry. Sorry, oh, I forgot to share my screen. Thank you for noticing this. Yeah. So I wrote this title here, simultaneous. This is probably wrongly written. Maybe it's neos, probably like this in English, or system of equations. And in Finnish we call that yhtälöryhmät. And this yhtälö word there, it's the same as equation in Finnish. And this ryhmä here is, I think best translated in English it is group, or in plural form, groups. In many Finnish words, where if they ends with the letter T, that many times is plural of the third word in front of that T letter. Equation groups. And now I will take some ways to solve those systems of equations. There are many ways, but I will take some. I guess many of you have used to solve this kind of equation already, but sometimes you may have forgotten or what you have learned a long time ago, and maybe you may have some own ways to solve these equations, but I will take some usual ways. And I will start with example, and I will take a yhtälöpari, or in Finnish yhtälöpari. This is same as pair of equations. Maybe you can understand this. Yhtälö is that equation there, and pari is almost same as in English pair. I think it has some similarity, this pari, pair. And let's take some example. For example, if we have this kind of equation pair, or pair of equations, 2x minus 3y equals 7 and 5x plus 4y equals 10. this was just two equations. So the most important thing is to notice that in pair of equation we have two equations, and there is two unknowns. So there are two equations and two unknowns. In English, in Finnish, this unknown is called tuntematon. Tuntematon. Very famous Finnish movie is this is actually nothing to do with mathematics, but to learn to somehow to learn something about Finnish culture. A very famous Finnish movie is Tuntematon sotilas, and this is unknown soldier in English. So there is the tuntematon word. And to solve this equation, we have to solve both x and y. So after we have solved this equation pair or pair of equations, we know both unknowns. We know the values of the unknowns then, so they are not any more unknowns. And there are many ways to solve this. One way, and I think it is the most useful way or method which works every time in every or in almost every pair of equations, is that you choose one unknown, x or y, and you choose one equation, first or second, and you solve that one unknown from that equation you choose. So I may choose whichever equation and whichever unknown there. So for example, I may take this first equation there. I will number these 1 and 2. So from solution, I will solve from this equation 1 the unknown x. Eli let's solve x from the equation 1. So actually we don't get the value of x yet, but we get a way to write x in with the help of y and maybe some constant number there. So first I solve this first equation, so I will write it again here. First I will solve 2x, so I will move this minus 3y to the right hand side of the equation. So I will get 2x equals 7, and this minus changes to plus when it moves to the right hand side. So 2x equals 7 plus 3y, and after that I may divide this by 2, so I will get x equals 7 plus 3y per 2, or divided by 2. And after this I have many possibilities to continue. One method is to substitute the x in the second equation with this sentence or this expression there. But actually I don't like that method. It gives us so nasty equations. I rather do so that I will do the same for the second equation. So I'm going to solve the x from this second equation. Let's solve x from the equation 2. So I will do the same with this second equation. I will move. I want to solve the x from that equation, so I will move this plus 4y to the right hand side, so it will change the sign again. So I will have 5x equals 10 minus 4y. And then I will solve x by dividing this equation by 5. So I will get x equals 10 minus 4y divided by 5. So now I have solved the x from both equations. In the same time, or at the same time, the x equals this here and x equals this. And this is the same x. So that means that if there are same x's in the left hand side, so these right hand sides have to be equal also. So I can make a new equation, let's call that equation 3, so that I will write this expression equal to this expression. Let's write the third equation. Seven plus 3y divided by 2 equals 10 minus 4y divided by 5. I will box this here so you see it clearly what I did. And now we have this third equation. It is the equation where there is only one unknown. Only this y is unknown. So with this equation I may solve this and to get the value of y. So from this equation I will get the number value of this y. These x's I solved earlier, I don't yet know the number value, but I know only these expressions, how they can be expressed with the help of y. And here always or almost always this equation or this third equation is this method. In this method it is this kind of equation which is most easy to solve by cross multiplication, because there are these kind of divisions in both sides of equations. So this cross multiplication is the best way to, or at least in my opinion, is the best way to continue. So 5 times the top of the left hand side and 2 times the top of the right hand side. Of course those multiplication is possible to do immediately, so we don't necessarily need these bracket intermediate states there, but with the simple head counting I may get the result from this step to the next, this step I'm writing now. So I will get 35 plus 15y equals 20 minus 8y. And this is a very easy first order or first degree equation. I will move y's to the left hand side and simple numbers to the right hand side. So this will move there and this will move there. And now they are moving to the other side of the equation, so the sign will change again. 15y plus 8y equals 20 minus 35. 23y equals minus 15. And then last step is to divide the 23 away from the left hand side. So I will get the answer, this y equals minus 15 divided by 23. Of course I would get the calculator and check what is the decimal value of this, but I don't do that yet because I need this more exact value. It is more easy to use this fraction form than the decimal form in the beginning, when I continue to solving the value of x. And now I have two possibilities. I have here x equals this, or x equals this, and I may choose which I would like to take. Well, actually, maybe it's easier to take this one here. There is no minus signs in this, but it doesn't matter which one we choose. We will get the same value for x. So we will use this equation here, and then we substitute the y letter with this number value I got. So I will use this knowledge there. So I will get x equals 7 plus 3 times minus 15 divided by 23 divided by 2. It is not very nice equation. I should have thought before I take these numbers to the equation, because this is not so easy to solve, but we can manage, I think so. 7 plus 3 times 15 is minus 45, and divided by 23, and we may 23, this is better to get rid of this 23 in the bottom of this fraction, so let's multiply with 33. This is actually not necessary if we only want to get to find out the decimal value of the x or y. So these steps are not necessary, but I like now to get the answer in fraction format. So I will do this. 23 times 7, 100. Is it 61? If I make error, just tell me. And then 23 times this fraction here, so this 23 will be, we get rid of them. We may cancel them out, so that leaves only this minus 45 there, and in the bottom there it is 46. And the final answer is 100. Is it 16? I hope your camera won't see that I am using calculator here. I am doing all my countings in my head. Yes. Okay, and then there are, this can be also, so there are even numbers there, so I would divide it by 2, so I will get a more easy fraction there. So it is 58 divided by 23, and this is the value of x. So now we have got the solution. The answer is, let's put this x first. X equals 58 divided by 23. I will get the decimal value for that, 2.521, etc. And then y minus 15 divided by 23 equals minus 0.6521, etc. So this is our final solution of this problem. And we may also check the answer. I will not write it in the paper, but when we have this original system of equation or equation pair or pair of equations, so I will check that if I have those numbers in my calculator, I will check that what I get if I calculate with my calculator 2 times x minus 3 times y. So 2 times x was this number. I'm not sure if you can see that correctly. I check that, and then what was the equation? There was minus 3 times y. This is y. So now I have those numbers there, and my calculator gives 7, and it's the same as in the first equation. So those numbers or those values of x and y, they solve this first equation, but it have to solve also the second equation, and let's check that. 5 times x plus 4 times y. So I'm not sure why does it show now. So now it gives 10, and as you see, it was in the right hand side in that for the second equation. So we have checked that this answer actually is the correct solution for that system of equation or pair of equation. This method is very universal. This way you can solve every pair of equations, but this is not so. It is quite easy when you are doing it step by step, but many times it is quite nasty to check those calculations, even though you have done these calculators yourself. This method is quite messy, and there are lots of steps where you can make mistakes. So I will take another method, but I use the same pair of equations. So another way. By using so-called Cramer method or Cramer rule. And this is the method which uses the determinant concept which we had earlier when we calculated and unfortunately I don't have the lesson notes from earlier lessons right now with me, but we had the method where we calculated the area of polygon, and it was this method which we used. We had this polygon here, and we knew the coordinates of those vertices of that figure, and used this method where we have this determinant concept there. And I think I'm sure if we use this formula book, but here it is told that the second order determinant is calculated by, where is my determinant here, determinant of two rows, and it was this kind of notation, and this notation or determinant notation just meant that you have to calculate multiplication or product of these two numbers there. So it is this multiplication or product there, and then you have to calculate the product of these numbers there, and it is there, and there is minus sign between them. And in this grammar method we use the two determinants of two rows, so this kind of determinants. And in this equation book or formula book, in the next page it is told this is the grammar rule. Well, in this book it has only the name or title solving pair of equation with the help of determinants, but this is called actually the grammar rule, and it is quite easy method if you learn to use that, and I think it's more simpler. But of course there is many times if you find a easy way to solve something, many times you don't actually understand what you are doing. So this is some kind of mechanical way to solve this pair of equation, but the price from this mechanic way to solve that is that you actually don't understand what you are doing. So let's take this pair of equation again. I will take the same equation pair so that we can check if we get these same answers as we did with this more old-fashioned method which we used earlier. So we have this and in this method we make three determinants from those numbers we see in that equation or those equations. The first determinant is easy. It is a determinant made from this left hand side of this system of equations, and it is the determinant which we use only these number values. We don't use these x's here or y's there. We just pick those numbers there. So the first determinant many times is called simple D or uppercase D, comes from the word determinant in Finnish, and this is always the determinant from these numbers in the left hand side of the equation. So we have 2, we have -3, we have 5, we have 4. So these are the factors of the unknowns. still have these bad pens here. I should throw them away. Vectors of unknowns, or the coefficients of unknowns. And in this method we have this determinant here, and as I showed earlier, the method to solve the value of the determinant is the product of these minus product of these. These first and then these. So in this case the value for this d is 2 times 4. So the product of these minus, there is always minus sign in this method, and then we take the product of these, so there will be 2 minus signs there because there is minus 3 times 5. 8 plus 15, 23. So actually, if you remember the earlier method when we solved this same pair of equations, as you see in the bottom part of these fractions, 23, and here also 23, and we can see that this is the same number value. So this is how easy we got find out the nominator of these fractions, or these numbers. And then, as I told, this is the easiest of the determinants. Well, these other two determinants are not so hard to understand either. So I will show from this formula book. First we made this here, and as we see here, we had A1, B1, A2, B2, so those were the numbers in front of those unknowns there. We made that. Then we have this determinant which has the indice of x, dx. And how does that differ from this first determinant? The second column is the same, but the first column is not the same. Here we have A1, A2, so they were the numbers in front of x's here. But here we have C1, C2, so in these equations, those C numbers there are the numbers in the right hand side of the equation. So in this case, those C letters are these numbers here. So what are we doing here actually? We first pick those numbers in front of those unknowns here, and then when we solve the determinant x dx, we just substitute these first numbers here in both rows. We substitute these numbers with these numbers. So these will be, I will cut them away. I have scissors there, and I will take these away and put these in the place of them. So I will get this. So in this example, this dx we get by changing the numbers in front of x. We are calculating dx, and we change the numbers in front of x to the numbers of in the right hand side. So in this case it is 7 and 10, and these two numbers they will be the same as in this d determinant. They are the numbers in front of the y unknown. So we have -3 and 4. And after this we have a very simple calculation left. Again we will multiply these numbers and multiply these numbers and put minus sign in between them. So 7 times 4 minus -3 times 10. 28 plus 30. equals 58. And when we compare this this number with this solution of x, we had 58 in the top part of this fraction. So this is the number which comes there. So x we can solve by dividing this number by this number. So this is quite easy method to solve x. But as I told, it is very hard to understand why does this give you the right solution. But for me this is enough, and I hope you are satisfied also to get right answer with the help of this method. Of course it is possible to prove this, but it takes so much time that I don't want to do that, and probably it is not useful to see the proving of this theorem. So now the solution of x we get by dividing dx by d. It is 58 divided by 23. And the same way we continue to solving dy. And when we remember what we did with this dx, we had the first determinant, which was those numbers in front of those unknowns, and we changed the first column with the numbers of the right hand side of the equation. So I took these and put them in this place, and I got this. And that was how we did this dx. And now we are calculating the value of dy. Yes, I will write this formula. Yes, that's right. I will go through this example to the end, and then I will write this formula in the, not in the chat, but I will write it in this paper. It is not so easy. Or is it easy? I will try to put it in the chat. Let's see. But not yet. So dy, we took the same logic. So we had this determinant here, and now we are solving y. So we will substitute the numbers in front of y unknown to these numbers. So I will take these here and put them into this place. I will have 2, 5, 7 and 10. And again, multiplication or product of these numbers minus product of these numbers. 2 times 10 minus 7 times 5. 20 minus 35 equals minus 15. So when we compare that to our result where we solved the y here, we got also the minus 15 there. So that is the number which we write in the top part of that fraction. So this y equals dy divided by d, or minus 15 divided by 23. I will try this method if I can put this equation. Unfortunately it is in Finnish, but it is easy to understand what that means. Try to get this. Wait a minute. Oh, I managed to do it. I'm so happy. Now it is in the chat box, that formula. Yes. I will do so that I will give you some problems to solve. We are having a break here, 15 minutes, but during the break, if you want to practice this method, I will give you some problems, or one problem, if you have time to do that in our 15-minute breaks. I will take a pair of equations which I know the solution, so I don't have to do that work. Let's take this. By the way, if you use the Kramer rule and we have this kind of equation where there is only simple letter x there, so remember that in front of x there is 1, so this is actually 1 times x. I will 1 times x plus 2y. So in this grammar method you need to get a number value there, so it is not 0, it is 1 there. If this would be minus x, so it would be minus 1 times x, so it is not 0 there. If there somehow is, if there were not, for example, this x in the equation, it would be like this. So this is mostly so easy to solve without any grammar rule, because if we don't have this x here, so it is very easy to solve in counting heads, so that we get the y value must be 30 in this equation. 2 times 30 equals 60, and then when we know the value of y, we can substitute in the second in the first equation and then solve x. So this is possible to solve very easy. But if you want to use grammar rule in this kind of equation, then you have to put 0 in the place of x there, because 0 times x is same as 0. Yes. So let's have a 15-minute break here. 15 minutes break. In Finnish time we have 13:11 now, so it will be 13:20. Let's put 25 there. Yes, there was a question about truncated cone. I will try to find the formula for the truncated cone. Did you already solve? Actually, I don't remember. So you mean this kind of figure there? Yes. So there is a formula for actually I don't remember if I showed you this. This is a misspelling there in Finnish. That is not this kind of letter. It this A, there should be two dots in top of that letter A there, ympyrä, kartio. This letter is so-called Swedish O, so if this is pronounced exactly as this O here in Finnish O. What is the question? What is the word? So the volume of this, or what is? I don't understand the word of raho. Raho, is that misspelling? Or are you using the or thinking about the assignment? What is the number of that assignment? Where this kind of figure comes up when you are. Yes, I will try to find that here. Actually, you don't need this formula in that assignment, because there is not we are not asked to solve the volume of that figure, but I'll try to open my Moodle page. It is this problem. Try to get it a little bit bigger. Yes. This is assignment number 111, so nobody has these values there, but I am very much problems with this now here. So actually this means that you are making this kind of truncated cone from this paper, or what is that called? Is that paper or some maybe, for example, paper, and first you have this kind of round or circle paper which has a form of circle, and then you cut away this sector, so this orange part is taken away, and then you also cut this part, or this is somehow, is it light blue color there, or is that some kind of violet or this color there? So the only this yellow part is used when we are doing this or making this truncated cone. So in this case you need just to the values of the radius lowercase r, so that means the small radius here, and then the radius of this big circle, so this uppercase r is this big radius there, and then the angle alpha, which is this angle here. So with knowledge of that, you can solve the length of this perimeter of these small circles here. So this blue circle here is the length of this blue circle there, or the border of this blue circle is the same as the length of this part here, only this part, and the length of this perimeter of this bigger circle there, this red circle, is the same as the length of this part from this to this. So you need to solve with this angle the length of these arcs of the circle, and those are the perimeters of these circles. And when you know the perimeter of those circles, you may count the radius of the circle. And you may solve that by using the value of that angle alpha. Because, for example, if the angle would be 180 degrees, so half the circle. So if that angle would be 180 degrees, then the length of this line here, or this arc of the circle, it would be half of the length of the arc of the whole, or perimeter of the whole circle. And now if it, for example, is 201 degrees, so yeah, you are seeing taking 201 parts of the 360 total parts of the perimeter of that circle. 201 divided by 360 times the perimeter of this whole circle. Always those assignments, if you don't need to solve that assignment to the end, if you can start the solving and then you get problems, you may send the solution what you have done to that point and ask help to continue. It is always possible.